Hello everybody, I'm Xavier Labandeira, Director of FSR Climate at the European University Institute, and I want to welcome you all. We have now about 55, 54 people attending, but we have more than 200 people registered, and we hope that they will join us during the debate. Probably this is going to be one of the most successful online debates ever organized by FSR Energy and Climate, and we have several that you can check in our websites. And this indicates that we are probably dealing with a very hot topic with a very impressive set of participants. And I hope that we will use well this 1 hour that we have for the online debate. So the panelists have already joined me. And let me start talking a bit about the topic of the online debate very briefly. And then I will introduce them and I will give some information on the way we will organize this online debate. So, as I said, this is a hot topic. Many people are talking about this in the last few months. And we decided to do this online debate to try to put some order and also to be able to debate with numbers and ideas on such an important topic from almost everywhere in the world. It is clear that climate change is a pressing issue. We are seeing worrying data as in the last few months, weeks, and it seems that there is a sense of urgency to act. Also, we should expect relevant policy actions in the next few years as national determined contributions are formally presented when the Paris Agreement is ratified by the different parties. And we expect this to be done in the next few months. And of course, these actions have to be implemented in some sectors, and electricity is a key sector because, as you know, most of the emissions in many countries come from this sector, but it is also a sector where many possibilities to abate, to introduce reductions in greenhouse gas emissions can arise. And this is the core of this debate. In this context, what is the best way to deploy, to develop renewable capacities in a centralized, decentralized manner? What is the role of batteries in all of this? Centralized, decentralized, to get mitigation? And also, what are the wider implications? We want to focus a lot on climate change mitigation because we are FSR Climate, but of course I'm sure that we will need to deal with other issues. To do so, we have 3 world-leading specialists. First, we have from Boston, US, Professor Richard Schmalensee from MIT. He's one of the most relevant energy economists, as you all know. So thanks very much, Richard, for being here and welcome to the group. In Paris, we have Laszlo Varro. He's chief economist of the International Energy Agency, and you all know his relevance in the energy debate in general and in particular in this field. So thanks for being here, Laszlo, and welcome to the debate. And finally, from Madrid, if I'm not wrong, we have Santiago Blanco, who is director of DNV GL from the Iberian Peninsula and also an expert in this area. As you could see in the video he prepared, and the other two also prepared 2 very interesting videos as a warm-up, also as a way to help attendance in this very, very interesting debate. So I hope that all of you have, or most of you have accessed these videos. Also, they will be available after the debate, and we will make all the information and all the recordings available in our website. Let me tell you, before I give the floor to the panelists, that we value a lot interactions with the participants, and they are growing up, and now we are 72 from 53 minutes ago. And with these participants, what we wanted was to check their opinions on different topics, and I'm checking just one thing we asked, which is what is the level of the impact of the centralized energy generation in reduction in reducing carbon emissions. And as you can see, most people think that this is a very relevant issue for greenhouse gas mitigation. 47% think that the impact will be high, and 42% think the impact will be medium. So this comes from the registered people. They also answered other questions that we will probably discuss at the end. And we invite you to participate with questions in this online debate. So I will give now 5 minutes to each of the participants, of the panelists. Then we will use around 10-15 minutes for questions between me and them and interactions between them. And hopefully I will be able to keep half an hour for the many questions that I'm sure will come from all over the world. So thanks again for being here to all of you, and we start the online debate with Professor Schmalensee in Boston. So Richard, the floor is yours. Richard, I cannot hear you, so perhaps you have to. Yeah.
Can you hear me now?
Yeah.
Sorry about that. This will be interesting because looking at the other two excellent videos, I think we're in violent agreement in the sense that distributed, decentralized renewable generation, primarily rooftop residential solar, is more expensive than alternative renewable technologies. And so it seems unlikely that it will play a major role. My colleagues may disagree, but of course that's going to be politically determined as well as economically determined. And so it's a little hard to forecast. I think it'll play a larger role in the short run than in the long run. Let's remember that to stabilize the climate, the world needs to get to net zero carbon emissions. That's an enormous change. An enormous change, and I simply don't believe that at the costs relative to other approaches that much of that enormous change will be driven by decentralized production, that is to say rooftop production.
Thanks, Richard. Yeah. Laszlo?
I think it's worth making a distinction between two potential contributions from decentralized energy resources. One is when we produce primary energy in a decentralized fashion, and with the current state of technology, that is only rooftop solar. Theoretically, you might imagine a state of the world when we have, for example, decentralized small-scale fuel cells running on some special biogas technology which turns your household waste into electricity. This was seen in the Back to the Future movie, so it should be available today in the Back to the Future. But as of today, decentralized low-carbon production is only solar PV. Now, solar PV can be rooftop, but outside Europe, in very important regions, including the United States, China, India, and the Middle East, the majority of solar investment is not decentralized. The majority of solar investment is large utility-scale PV farms. This might change in the future, but we think that even in the case of solar, there will be a quite robust component of large centralized solar units. Having said that, the decentralized solar PV benefits from the consumer excitement. So it is fashionable, it is an expression of the green sentiment of the consumer. Very often it benefits from special policies. So we think that there will be a significant role for decentralized solar PV. But for solar PV, there is an inherent limitation. No matter how good our solar technology is, the sun goes down at night. No matter how good our solar technology is, In temperate climates, so in New York, in Europe, in Tokyo, there is a big difference between the summer and winter. So that will limit the share of solar in the total primary energy production. And we very firmly believe that the future low carbon energy system will rely on a diversified portfolio of low carbon sources. Now, the other big question of all decentralized resources will play, if we use the energy resource in a broad sense, also incorporating electricity storage and also demand-side response interacting with smart grid technologies. And there I'm even more optimistic about the use of decentralized resources, because we will have large-scale deployment into centralized but variable and weather-dependent technologies. So that would be the large utility-scale solar plants and all the wind power production. I mean, wind power production is not decentralized. Windmills are large, often located in remote regions, but their production is variable depending on the wind. Consequently, with a large-scale deployment of wind and solar, we have to increase the flexibility resources of the electricity system. Theoretically, you could envisage a power system where all the flexibility is provided in a centralized fashion. So large centralized gas turbine plants providing flexibility, large centralized pump storage hydro plants providing electricity storage services. But there is a very promising technological improvement in battery capacity. Electric cars are gathering momentum. So last year already 500,000 electric cars were sold. That's a historical high. Can you see me?
No.
Nope.
Something is wrong with this camera. I'm trying to restart. Okay. Okay, I'm back. Am I back?
Yeah, Laszlo, we can see you, but it would be good if you could increase your mic from the top bar, because we are not hearing you that well. So.
Okay. How do I do that? I try to get closer to the mic.
Yeah, that's good. Perfect. And Richard, we were listening. I was told that we were listening to you too loud, so the opposite way. Anyway, Laszlo, please continue.
So we see promising technological progress in batteries, both for stationary applications, also for electric cars, and also we see innovative new business models emerging for decentralized demand-side response portfolios, when individual consumers providing a small demand-side response, individually small, but then this is aggregated by some internet-based business model providing flexibility to the system. So if I add together the potential for charging electric cars to provide flexibility to the power system, the potential for stationary batteries, the potential for demand-side response, then the potential contribution for distributed resources to provide flexibility to the power system, we believe is quite significant. However, that also requires a different approach for energy regulation and a different approach for infrastructure management. And I think that would be a very interesting thing to discuss. How do we get there?
Thanks, Laszlo. Santiago.
Hi, thanks for the invitation to participate in this very interesting roundtable. I think that we agree basically in the main concepts. From my side, I will just to focus in 2 or 3 points. Basically, the first is that the challenge to move our energy sector to a sustainable, affordable, and reliable system is a huge challenge. So from our point of view, there is not a contradiction between different technologies. There is a collaboration between them. And obviously, until now, for example, wind technologies were clearly the most mature and the most competitive ones. But it's clear, I think, that now solar, after 8 years reducing the cost more than 10%, of almost 15% year by year, I think that it's clear that it's now a key player in the present and in the future of the energy sector. Second, I agree that in most of the countries, the utility scale and industrial segments are the most important, but we can also agree that the commercial and residential, mainly the rooftop PV, are very, very, very interesting. Perhaps not as big as the other, but very big to be considered as a relevant player. No? We did a study that we summarized it in our presentation, showing that the complexity to integrate these kind of technologies at a distributed level for the system is huge. The advantages are big, but for us it's very, very important to take in consideration that the market, the business, the sector is changing completely, and we think that it's very important at this moment to continue supporting the competitive utility scale renewable investment, but at the same time to send clear retail pricing signals to the customer to empower them to freely participate in the market, but at the same time taking care of not being sending unfair or not transparent signals to the customers. And finally, and very important for us, we need to consider, as Laszlo commented, the need to implement a lot of flexibility tools to compensate the new system that for sure it is now and in the future will be much more complex. Now, so demand response, smart grid technologies, monitoring of the network will be key components to allow the system to receive as much sustainable and at utility scale and distributed level technology as possible. So, finally, we think that there is a new player that is entering the market now, the storage. And every study, every consideration that we can do at the present, we need to take in consideration that, like with solar, storage is reducing the cost year by year, and this will change most of the paradigms that we have. So I think that it's very important to consider at the distributed level both the solar PV, but also solar PV, demand response, electric car, but mainly and especially storage. Thank you.
Thank you, Santiago. Let me ask Richard. I mean, when I was listening to his video a couple of weeks ago, he was talking about this romantic approach to decentralized energy sources, and he was also discussing the distributional issues that were behind some of the policies in place. So I would like to ask you how these two things can combine in the political momentum or in the political problems of policies or of public strategies in this area.
Well, let me say first, I think it is important to reform retail pricing, retail regulation. To drive storage, it would be very useful to have price signals that reflected the state of the system instead of a flat tariff. We need to move to spot pricing to encourage storage. Electricity prices in wholesale markets are much lower at night than during the day. Storage permits arbitrage. Demand response will be effective, more effective, have stronger incentives when retail customers see prices that reflect the state of the system. I agree with Laszlo heartily that I think demand response will play an essential role going forward. I think if we are to move to a seriously decarbonized electric system, it will be necessary for storage to play an important role. I'm less optimistic than either of my colleagues about storage technologies. Things have come down, but storage is not yet cheap. And I don't think the progress is as rapid as was suggested. But I think the real challenge is going to be harnessing technology to enable retail customers to respond automatically to time-varying prices. When we move there, and when that technology becomes deployed, it'll be possible to make use of electric cars in the system. It'll be possible to make more use of demand response. It'll be possible to get the incentives for rooftop and utility scale solar balanced. So I think reforming retail rate setting is critical to driving these technologies and to moving the system forward.
Any interactions between the other participants in the panel?
Yes, I think when we discuss how big the role of decentralized generation will be, I think it's worth making a distinction between big in annual average primary energy quantities or big in terms of impact on the electricity network, impact on system operation, impact on regulatory regimes. So, for example, if you take the United States as the example, if you put solar panels on every single middle-class home in the United States, in annual primary energy consumption, it will be still less than the current nuclear production that we have in the United States. So it will move the needle, it will contribute significantly to electricity supply, but it will still be a minority part. However, if you start to put solar panels on every single middle-class home from New York to California, well before you would get to 100%, you would have extremely large impacts on the distribution network operation. It makes a real difference whether you have solar panels on top of a home which is air conditioned during the day, or whether you have solar panels on top of a home where nobody is at home and you have to take the electricity out during the day. Very similarly for electric cars, even if you switch every middle-class family to electric cars, the impact on electricity consumption is not going to be extremely large. The existing power plant fleet in most countries could supply electric cars for the population because the electric engines are so fantastically efficient. However, there is a huge difference between a society where electric cars are charged by being plugged in most of the time somewhere. Their onboard computer communicates with the system operator, and when the wind blows, the car eats the electricity. When the wind doesn't blow, the car stops charging. Or if you take a society where electric cars charge into a Tesla supercharger at 7 o'clock in the afternoon, all of them at the same time, and in that case, they will be part of the problem rather than part of the solution. So in terms of the capacity balance, I think distributed resources, both solar PV and storage, will play a very, very large role real soon. In terms of annual average energy quantities, we continue to rely on a highly diversified set of low-carbon resources, including wind, hydro, nuclear in several countries, and so on.
Santiago? Can you switch your mic, please? Yep.
Yes, sorry. No, I agree with Laszlo and Robert about the relative importance of the distributed generation. But again, I think that the impact in the distributed level of the system, I think that will be very big, but I agree. Depend on what we consider big. No? But for example, in our study, when we evaluated penetration of around 10% of the total generation or the total consumption of the system, it could be considered very small, partially, but at the same time, at the mid-voltage or low-voltage level and in very specific region, this could be huge. No? So I think that we can combine both answers, saying that perhaps it's not as big, but it's enough big to have a very big impact. But for us, again, the most important is to keep improving the way we promote and we support the integration of sustainable energy, and we think that is convenient to review. Each country is different, but to review the pricing to show to the customer the different price of the energy during the day, during the night, and the impact of this kind of clear signals to the customer. We think that will be the most important to promote or not the different technologies.
Okay, we have still 5 minutes to 3:30 here. here in Europe, and then I will ask you to deal with the questions. I mean, you are seeing in the left part down of your screens that many people are already asking questions. But I would like before that to take some messages, general message on very short message on the role of climate policies, existing climate policies or future climate policies in dealing with this issue, knowing what you think about the potentials that we have here, not so big or big in relative terms, as you want to say. So I would like you to give us a quick message before I go to the questions. So Laszlo, for instance, implications for climate policies, existing or future climate policies in this area.
Sure. I mean, if you run the numbers for our 2 degrees climate stabilization, realistically, you have to hit electricity sector related emissions fast and hard, and this is going way beyond what you can achieve with switching from coal to gas. In fact, in a credible 2 degrees trajectory, the average carbon intensity of power generation will have to go beyond the emissions of the best gas turbines in less than a decade. So the only way you can achieve that is a very large scale, very fast deployment of low carbon electricity production. Now, large scale centralized low carbon electricity production technologies do exist. Nuclear power already plays a significant role. Hydropower already plays a significant role. They will continue to play a role in the future. However, it is very difficult to imagine under realistic political ambitions the rapid and large-scale upswing of nuclear investment. That's politically unrealistic in my view. Very similarly, there is a significant hydropower investment in China, in Southeast Asia, in Latin America, but in Europe and the United States, again, it's very unrealistic to assume a significant upswing of hydropower investment. So in reality, the overwhelming majority of new low-carbon investment in Europe and the United States is going to be wind and decentralized wind and solar PV. So that some of that solar will be decentralized, and all of the wind and solar will rely on the decentralized flexibility resources. So it's going to play an extremely important role to reach our 2 degrees target.
Thank you, Laszlo. Richard?
Well, you ask about climate policy broadly, and I would say one of the difficulties, certainly in Europe, certainly in the United States, is we are all avoiding the economist's obvious solution, which is rather than pick particular technologies and decide what to subsidize and decide what to deploy, there should be a high price on carbon. And as all economists know, the fact that Europe has a low price currently is attributable, at least in significant part, slow growth, of course, but also specific programs aimed at renewables, specific programs aimed at energy efficiency. The problem in the U.S. is rather different, since we have a major political party that denies science. But I would just say that rather than engage, when we talk about climate policy, rather than engage in the usual game of deciding what to subsidize, we should try to push hard across the board. That's going to result in movement toward renewables, but it will also result in a variety of other changes in patterns of living, in intensity of use, and a variety of other changes that won't be captured by just picking technologies. So I think one does want to step back from deciding which technology to deciding which overall policy.
Santiago.
Several years of different countries' policies, we have now the renewable energies or the renewable technologies competing in price. So I think that basically the climate policies should only focus in giving them, allow them to compete, to reduce as much as possible the different subsidies that in the world exist, and to try to allow the market to choose the most efficient and to choose the one that solves in the best way the energy dilemma of sustainability, affordability, and reliability. And I think that this is what the policies have to do now, that fortunately we have mature and efficient technologies.
Okay, thank you to all of you. I think that now I ask the audience to continue typing the questions. In theory, we would start now with the questions, and we have a bunch of them. So perhaps we could go first to Alexandra's question. Hello to everybody. What is the definition of decentralized energy generation? Is there one agreed at national, regional, and international levels? Is it only related to renewable energies? So who picks this question?
The answer is no. I think everybody uses the term to mean different things. When hospitals have emergency backup generation, that's a distributed energy source. My thought was we were talking in the context of climate change, we were talking about distributed renewables rather than distributed diesel generators. So I think here we seem to have an agreed definition, but I don't think we have elsewhere. And as Laszlo points out, in particular, one wants to think about storage as driving or as an energy source in this context.
I think a reasonable definition for that is the distributed resources interact with the grid at the low medium voltage distribution level, and the resource is very often behind the meter. So the conventional utilities extend until the electricity meter, and in unbundled liberalized electricity markets, the network companies extend until the meter. So consequently, when you have a solar panel on top of a private building behind the meter, that is distributed solar. Then you have a very similar solar panel on a field connected to the utility system. That would be a small-scale solar power plant. Of course, there is a lot of distributed diesel generation. There are something like 60 gigawatts of diesel generators scattered all around Africa and India. They do provide electricity, but they are dirty, noisy. They are not an attractive solution at all. So that's not a modern form of distributed generation. Very similarly for storage, there are utility scale storage investments. So there are utilities who are building storage capacity in a centralized fashion. And in that case, the storage facility is essentially a special power plant which is running on cheap electricity and providing peak electricity. But we will also have a significant scale emergence of decentralized storage capacities owned by private citizens in the form of electric cars or in the form of a stationary storage facility in the backyard.
Santiago.
No, I agree with the definition of distributed generation as basically a mid and low voltage network, and especially beyond the meter. I think that the definition of beyond the meter is clear to properly define the distributed generation that we are talking about.
I think the next, we won't be able to deal with all the questions because they keep coming, and I think that some of the questions were already answered by you. We go to Felix Fernandez, our decentralized approaches, major points, avoiding transport losses and promoting efficiency.
Well,
distributed generation can have a positive impact, naturally. So most of the network loss in an electricity system is taking place at the transformation from medium to low voltage and then the distribution at the low voltage. Right. So consequently, if you have distributed solar generation serving local load, you do reduce network losses quite significantly. However, if you don't have proper market incentives for the location of distributed generation, so you just introduce a no questions asked subsidy on every rooftop solar panel, you can end up in a situation that's prevalent in Germany, that's prevalent in Italy, when you introduce a very significant network load during the day when everybody has a rooftop solar in a village, but nobody consumes electricity during the day. So you have to take the solar production, you have to transform it up to medium voltage, take it out to a different region, and in this case you don't lose. You don't gain on network losses. So you can have potentially a major positive impact on network losses, but in that case you need micro-level markets providing good incentives for the optimal location of the solar panels.
We've done studies at MIT, colleagues have done studies at MIT of increasing solar penetration, distributed solar penetration on test networks, and above low levels, the reduction in losses is swamped by the cost of investments to reinforce, both to allow for the sort of reverse power flows that Laszlo just mentioned, but also to maintain voltage levels. When you all of a sudden have a generator on somebody's rooftop at the end of a long feeder, you can exceed voltage limits. That can be dealt with, but it's not free to deal with it. So at least in the studies we've done, the losses in transmission the savings in transmission losses tend to be swamped by the investment costs needed to reinforce the network.
Yes, in our case, we did a study, and the result was basically the same. I think that the implementation of distributed generation could have another benefits, but it's not logical to define them with the idea to reduce losses or reduce investment.
Next question by Carlos Albero. I think that we also discussed this. How will grid operators handle the energy inflow coming from thousands of generation sources? Is the IT of the distribution grid prepared to handle this? Do you want to incorporate any further thoughts on this?
Yes, I can answer. I think that the idea of the national or central system operator managing the transmission and the whole system now is necessary to add at the distribution level what in Europe some people is defining as the distribution system operator, or the DSP in the American, for example, in New York, the platform to manage all this new complexity in the mid and low voltage level. I think that this is a big challenge, and we are working in several projects on it, and clearly the distribution companies will play a key role to support all this new implementation, and the technology again will be key to ensure that the reliability of the system will continue the same.
At the end of the day, with significant solar penetration, the central operator has to be able to curtail rooftop generation under some circumstances. And it's my understanding that's not generally possible now, possible in some places, but that's important, because without the ability to curtail, it's quite possible to exceed limits on transmission lines.
Let's go to the next question. Carolina Burgi. How do you see the potential of concentrated solar power with storage as a regulator of the supply of renewables? Do you see it as an important factor for the increase of decentralized energy resources and as a key aspect in less classical sources dependency?
Well, let me jump, because we looked kind of hard at that. Concentrated solar power has the advantage that it sort of has storage built in. So when it works, it can essentially act as a dispatchable source. It has two disadvantages, three in this context. First, its costs decline with scale. So it really doesn't make sense as a distributed source. It really needs to be utility scale. Second, It doesn't function well in areas with clouds. It needs direct solar radiation. That really limits its deployment. North Africa, the California, Arizona deserts, yes. Most of the US, most of Europe, no. And third, even where where the meteorology is suitable, it's expensive. It's more expensive than photovoltaics. So the sense of my engineer colleagues is that it can get better, and its advantage of storage is a significant advantage, but it's not going to be distributed, and it's not going to be suitable for deployment in most of the world.
Laszlo?
Yes, the most important reason of the amazing cost decline of solar PV is that a solar panel is a semiconductor electronics technology which is very well suitable for massive scale mass manufacturing. So the Chinese electronics industry is manufacturing 4 solar panels every second. And this modular mass manufacturing technology, this brought down the costs by 80% in the past several years. Now, concentrated solar plants are more like oil refineries or conventional power plants, gigantic steel structures in the middle of the desert with a lot of heavy engineering, where it's very difficult to see the type of modular mass manufacturing effects that brought down the cost of solar PV. So we shouldn't expect the type of revolutions. Again, having said that, sure, once you have several plants built, there will be some project engineering experience, there will be some efficiencies, things can get better. We see reasonably good prospects in some countries where the solar resource is absolutely brilliant, but peak electricity consumption is around sunset. This is the case in, for example, Morocco. This is the case in Egypt. So these countries are extremely sunny, and they have 8 o'clock in the evening electricity peak demand, which, despite the very strong sunshine during the day, limits the usefulness of solar PV and makes concentrated solar an attractive proposition. The largest concentrated solar plant in the world is under construction in Morocco. Similar stories in South Africa, and another interesting hotspot is Chile, where you have extremely good sunshine in the Atacama Desert and almost continuous base load electricity demand from the heavy mining operations. And there again, there are some very interesting concentrated solar investment ongoing. But in the big scheme of things, it's more like a niche application.
Yeah.
Okay, thank you. Let's go to the next couple of questions by Claudio Marcantonini. What is the role of policy and of the market in developing these decentralized resources? And is it enough to set the right price of electricity to develop them?
As a former electricity regulator, I can tell you that this is a very complicated question because yes, you at a philosophical level, it is enough to set the right price of the electricity. But the right price is a very complicated question because for an electricity system, location and time really matters. Now, at the wholesale level, there is a good experience with real-time electricity pricing. Some European, some US markets now have real-time trading up until 5 minutes to gate closure. It's in a very sensitive manner. And also at a transmission level, some US regions have a very favorable experience with locational marginal pricing. However, extending this to the distribution level, where you have an electricity pricing regime where an individual storage operator or an individual electric car parking in front of a cinema gets the real-time price signal, which is of the proper price for that location at the proper moment. That's a formidable task. That's a formidable task for the regulators designing such markets, for the market operators, for the IT providers. You move down to distribution levels, and it's an order of magnitude bigger data problem. So that we are not yet there. In most electricity systems, distribution regulation is based on a 1970s technological paradigm. A bygone word which was relying on big centralized power plants and the electricity flowing top to down. We have to move beyond this paradigm, and we have to introduce the proper value for space and time.
I agree completely, but I would just add to it that in the foreseeable future, policy will play a critical role, because getting the price right, including having the carbon consequences of electricity generation properly in the price, as well as time and location, it will not happen soon. And so universally, I think policy will be aimed at renewables and low carbon sources, and for political reasons, favoring distributed resources.
Okay, next question. Yeah, Santiago, please. Sorry.
Oh, sorry. I think that is clear that I referred a couple of times about the transparent and clear signals to the market, but completely agree that this is not enough. The implementation of the renewable energy in the market, and also the distributed generation, clearly needs of policies, and clearly needs of to continue pushing the implementation of renewable, the improvement of the system at both transmission and distribution level, the definition of, I agree completely, to the recognition of the time and place special characteristics of the energy. So I am not an expert in policies, I am more an expert in energy, but I think that the policies will play a key role in the next year, for sure.
I stay with you, Santiago, because next question is about Spain, and perhaps could you like to give your opinion regarding the incentives in the PV Spanish regulation? Don't know whether it's too wide or whether we have any comment on this.
Well, in Spain we have an additional, I don't know if problem or characteristic, that I think that most of the European countries will reach soon. That is that we have an excess of installed capacity. We have the peak demand in Spain is around 40 gigawatts, and we have 110 gigawatts of different technologies. With for example, wind with around 25 or 24, and solar with 7 or 8. So the main challenge, the first challenge before the promotion of distributed, or at the same time, is what to do with all the other technology that we have, including nuclear, including hydro, including coal and combined cycle. So I think that this is another topic. I am not an expert in policies to discuss perhaps about this, but the challenge of the implementation of, we need to continue increasing the penetration of renewable and also distributed, but if we decide to remove the other technologies, this will have a cost. And I think that in Spain, clearly during the last years, we have several very big financial problems that was impossible, or perhaps is a limitation for the future, to continue implementing the renewable and distributed generation. Fortunately, last month, or a couple of months ago, we had a very successful auction in Spain with the utility scale wind farms competing at the same price as the rest of the pool. And I think that this was a clear signal of the future step that we have to follow in Spain. Distributed generation will compete in the same level of efficiency and competition with other technologies and with other technologies.
We have indeed a lot of followers in Spain in this online debate. I would say that at the end you will be able to see it, but many people are following us. That's why we have probably this question. So the next question by Michele Gaspari: what will be the role of business models in the adoption of distributed energy resources? I don't know whether, Laszlo, you want to add a bit on this?
Yes, as a consumer, I'm lazy. So any demand-side response or any storage model which relies on the assumption of me taking a conscious action will fail. Okay, so I commute with an electric bike. I plug in that electric bike every evening when I finish walking the dogs. and I'm not going to walk down to the basement at 2 o'clock at night to plug it out or plug it in. So the successful demand-side response models deploy aggregation techniques which overcome my laziness. So typically, you have an aggregator who would communicate with my smartphone, who would have a gadget, who would provide some lump sum incentive, and everything is then automatized, and I don't have to take any conscious action. I think this is extremely important because consumers in reality are not microeconomics 101 optimizing machines. They value their time, they value their convenience, and consequently, there will be a need for the smart business models which can provide the same convenience for the consumers by utilizing the flexibility options which is inherent in the appliances.
Thank you, Laszlo. There is another question by Maria Jimenez, and perhaps Richard. I mean, she's asking about fixed costs and who should pay for it. It's the next question. I don't know whether you can read it.
I see it.
Because it's a long one.
Yeah.
So perhaps
it's a long one. It's a hard one. In the U.S. and I think in Europe and most other countries, we have traditionally recovered those fixed. She asks how the fixed costs of the electricity system should be paid, and they do need to be paid. We've traditionally spread those out and covered them by adding to the per kilowatt hour cost paid by retail customers. And that sort of seems reasonable if you think about it, that people who use more electricity should pay more of the cost of the network. It's not efficient, particularly because people with different usages can impose different costs on the network depending on when they use electricity and where they're situated. But it hasn't mattered much historically that that's a little bit inefficient. Now, with solar panels, the fact that it's inefficient gets to be serious, because I might use, suppose I'm net zero, I have storage, I have a solar panel, all I do is rely on the grid for backup. Well, the way we price electricity now, I would get that for free if I don't use the grid regularly. We need to find, and the other problem is, at least in the U.S., people who put solar on their rooftops tend to be wealthier than those who don't or can't. So those fixed costs get shifted from people with, and so you have to raise the per kilowatt hour charge to cover fixed costs. That gets paid more by people without panels than with panels. That is to say, it gets shifted from wealthy people to poorer people. That's producing a political backlash here. I don't know about Europe, but we need to move away from the system of recovering fixed costs through volumetric charges. That's easy to say. How exactly we should do it in a way that makes economic sense, is understandable, and will be perceived by people as fair is a problem I don't think we've yet solved. Colleagues have complicated answers to that question, but none of them have ever tried, to my knowledge, to explain those answers to a real regulator. So I think we have a serious problem of moving away from the current way we recover fixed costs, and it's a problem that, to my judgment, is not yet solved, but it's an important one.
I agree. I think this is one of the biggest problems of energy regulation these days. We have an infrastructure asset, the electricity network, which remains absolutely critical for secure energy supply. In fact, in our view, with the large-scale investment of wind and solar power, the capital needs of the electricity network increase. So the amount that you save from potential efficiencies of distributed solar, that is less than the additional network capacity that you need to incorporate the centralized renewable resources, wind and large-scale solar. So you have an increasing investment needed in the electricity network. At precisely at the same time, the regulatory paradigm, which provides the financial remuneration for the network, becomes completely inadequate. And that is a major supply security concern. In fact, large parts of the United States and large parts of Europe are systematically underinvesting in electricity networks, and that's a big headache. I also agree with Richard that there is no easy solution for that. So there are some jurisdictions who experienced the easy solutions, namely that we just put up a plain vanilla fixed monthly charge, but more often than not, they trigger a consumer backlash.
Yeah.
So the regulators really have to be smart about this.
Let me take 3 more questions, and unfortunately we cannot deal with all of them. And one is related to the role of biomass. And Niccolo Rosetto asks for this, and indeed in Italy biomass is more important than wind when we consider distribution grids connected power. Anyone wants to deal with this?
Yes, the typical biomass utilization in the electricity sector is twofold. One, you take a 40 years old broken down coal-fired power plant and you convert it to burning. I have to say that I'm not enthusiastic about this model because in the renewable legislation, biomass is usually considered to be automatically a low carbon resource, but there is a rapidly accumulating scientific evidence that biomass can have very negative environmental impacts and can have very negative climate impacts depending on how the biomass operation, how the forest was managed and so on. So I think there will be limitations for that. In any case, those are large power plants. The other typical biomass use is biogas plants, which are, let's say, half a megawatt to a couple of megawatt size. You collect the local organic waste, sewage, as animal waste, and so on. You turn that into biomethane, and you localize in a cogeneration facility. Now, this is something which is very well suited for a low carbon energy system. It's very, really promising. But even these facilities are typically half a megawatt to 2 megawatt size facilities. So these are suitable for a village. These are not suitable for an individual household. In Japan, there is an emerging market of small size, 1 kilowatt, 2 kilowatt size residential fuel cell units. But even in Japan, that is something like a 10, 20,000 unit per year size market, heavily subsidized by the Japanese government. So the real biomass utilization is not decentralized generation the way we defined the phenomenon.
Okay, let me take the 2 more questions. One is by Alicia Carrasco. Is the model to accelerate the DG followed in New York with the DSP a good one to transfer to Europe? Santiago, Richard, any opinion on this?
Well,
Don't know it well enough to answer.
I think that the American, the New York policy is very interesting, but it's still relatively new, so it's very early. It's too early to say if it will be successful or not. But let me say that first, the regulation in America is very different than the European one. And second, I think that we have very interesting examples of the role and the pilots of the role and how the distribution company can play the role of a distribution system operator. No? Also defining or developing platforms similar than the DSP.
In general, it is very difficult to transplant an American regulatory model to the European context. The United States has a utility regulatory model which evolved over 100 years, and it's very strongly connected to the specificities of the American legal system. And that is not easy to transplant to a European jurisdiction at all. For example, many European countries have legislation in place which prohibits regional discrimination of retail electricity prices, because the government believes that for the sake of social justice, there need to be same electricity price in cities and in small villages. Now, of course, one of the very intellectually exciting characteristics of the New York Reform Program is to create markets at the local distribution level, which I think is promising, and I wish good success for New York. but it would be extremely challenging to transplant it into a European country.
Let me go with the last question. I know that we are on time now, but any strategies recommended for developing countries? This is by Dušika Kutmanović, one of the last questions in the list. Anyone wants to deal with this?
Yes, in developing countries, the most important thing is that we still have 1.3 billion people without electricity. Roughly half of them are in Africa, the other half of them in South Asia, India, Pakistan, Bangladesh. Now, these are regions which have a solar potential which is far better than anything in Europe. And also, when you introduce electricity in a poor village in Sudan, people will have a quite low per capita consumption. So already in Africa, around 6 million people every year get electricity without being connected to a centralized network in village-based, essentially solar plus battery electricity systems. Now, this is very promising, and this is a very good thing. And of course, moving from a petrol lamp to a LED lamp running on solar power is a huge step forward. However, even in Africa and in India, the majority of the electrification is done in a centralized fashion because of two reasons. One is that as people break out of poverty, they also want to buy a washing machine. They also want to buy a refrigerator or television. So their electricity consumption rapidly increasing to above a level which with a village level solar plant can supply. The second is that there's an extremely rapid urbanization. People leaving their villages and they move to Lagos, they move to Nairobi, they move to Mumbai, and the gigantic cities will always rely on a centralized electricity system.
I agree with all that. I would just add that the village scale PV plus battery systems are expensive in terms of per kilowatt hour costs, but that first bit of electricity is very valuable. So it can play an important transitional role, but it is a transitional role toward being grid connected.
Santiago.
Well, I agree with Laszlo that solar PV can be a wonderful solution in non-electrified regions, no? Combined with batteries, combined with backup systems. But the result of our study in this case was clear that in some scenarios of non-electrified network, this could be a very, very efficient way to deliver electricity in these kind of countries.
Okay, we are done. It's 4:03, and it was a very, very interesting debate. Let me try to summarize a bit. This is a difficult job for me because I had to manage the questions and three leading experts on this very difficult topic. But I would say that, first of all, there are opportunities in this area. You all agree with this. Cost went down a lot during the last few years on some of the decentralized approaches, especially for solar. New technologies are coming and may be coming in the future. And there seems to be a role for these approaches in greenhouse gas mitigation. Of course, there are challenges or problems. Costs are still high for some technologies, and in comparison to centralized levels, this is clearly the case in most cases. And also, we have to take into account the high costs of integration that they may pose, like network reinforcement, impact on dispatchment, etc. Finally, you agree that policies are crucial here, and they may be, rational or more irrational-based policies based on romantic or other ideas. Rational policies, Richard was very clear that we as economists think that proper pricing of carbon is a key issue, and it can contribute a lot to the proper deployment of centralized and decentralized approaches against climate change. It seems that electricity pricing should play a very big role, and therefore rethinking regulation of the electricity sector is probably around the corner in this area. So thanks a lot really to the three participants. I think they were great, both in the recorded videos and today. Professor Richard Schmalensee from MIT, Santiago Blanco, DAV, and Laszlo Varro from IEA. Thanks a lot, and thanks also to the participants. I mean, we had a continuous participation of around 100 people. I'm sure all of you will be able to see again these videos and the debate. And let me finish with the second of the questions. One, I mean, there were three questions in the registration. One, we put the results at the beginning, and the second was on the most significant benefit of decentralized energy generation for climate change. And for those registering, 42% thought that increasing production of renewable is the major benefit, whereas the following one is 25%, increasing demand-side management. Thanks a lot from Florence, and see you soon. Ciao.